Hello everyone and welcome back to the channel. In my previous videos, we had taken a look at multiple regression analysis, simple regression analysis, how to transition from simple regression to multiple regression. We had talked about different statistical analytical methods. We had looked at numerical and categorical and the different types of variables. I'm yet to do a video on datetime variables, and we had also taken a look at different statistical analytical techniques of numerical and categorical variables in applied statistics. Now in this video I'm going to be taking a look at how we can evaluate our model. So first we build our model, and then once we test our model on the test data, what evaluation metrics we typically use in machine learning to evaluate your regression analysis. If you hadn't seen my past videos, I highly encourage you to take a look at them, because in this video I'll not be covering all the concepts. I'll be quickly going through building the model, and then I'll be focusing on how we can build our evaluation metrics and evaluate them. Okay, so before we dive right into it, do not forget to subscribe to the channel for the latest of data analytics across Excel and Python. So let's get right into it. So this is the same data set that I used in my previous videos. It is the cars data set. It has the miles per gallon, cylinder, displacement and horsepower, and the other numerical and categorical variables. So I've divided this data set, 16 records I've kept it for the trained data set, and around 17 records I've kept for the test data set. Actually, we divide it mostly in the 70-30 proportion or the 80-20 proportion. Here I've taken more in the test just to show that how we can calculate and evaluate our model, okay, using the different testing metrics. So also we will see that how the model behaves differently. Earlier we had given more data, now with a different set of data, how the model behaves. This is a very important concept, because we use a technique called as cross validation, which is a topic for another day, to make sure that we know which parameters we have to tune in the model, or which model we should use to give us the better fit or the better results for our data. But that's a topic of discussion for another day. So let's dive right into it. Let us build the model again. Click on data, hit on data analysis, click on regression here, click on OK. So I'm just going to select these values again. So the miles per gallon here, this column, delete the values here, select the displacement and the horsepower, click on OK, click on labels, make sure this is checked, and let's place it here in this sheet, click on OK. And here your model is there. Let's take a look at some of the important values. If you want an explanation of what this value means, take a look at my previous videos. I'll leave a link to some of them in the description. So this is the adjusted R square. So this tells us that 41% of the miles per gallon, of the variability in the miles per gallon, can be effectively explained by the predictor variables, that is the displacement and the horsepower. So at first glance we can see that this is fairly less compared to our other model. I think we had achieved something around 0.77 or 0.78 if I remember correctly. So just by changing the data, you can see already this model performance has deteriorated. So that's why we use techniques like cross validation to optimize a model. So but let's take a look at this. So here 41% of the variability in the y variable can be explained by displacement and the horsepower. Let's take a look at the significance S. So of the significance F. So this is 0.015. So that means the regression analysis is okay. It is statistically significant, and it is a case for regression analysis. Let's take a look at the p values. So again here we can see the displacement is statistically significant and it's a good predictor. However, horsepower is not showing a good predictor here. It was showing a good predictor in the early data set. So, but for this case, I'm going to be taking all of these values to construct our model, because I want to focus on how we can do the evaluation metrics. Otherwise, we can choose different variables, and you can choose different types of combinations of variables to better build your model. So let's take a look at that. So let us build our model. Let us go to the test data, and here let us build our model. So first, I'm just going to copy the actual MPG here again. Once again, so that we can see it side by side when we make our predictions. So actual MPG, I'm going to hit on equal to and just copy these values. Okay, and let us do the predictions here. So now let us use our model. Let us make the predictions with our model. So predicted MPG, and let us now build our model. Okay, so equal to, I'll go to the, let me hit a bracket here. Let's go to the train sheet. I'll click on displacement first. Let's fix this. I'll click on into the multiple sign. Let's come back and click on the displacement. Then I'm going to close the bracket, plus again open the bracket, going to click on the train sheet. Let's do horsepower, sorry, let us do horsepower here, fix it again, okay, let's hit F4, multiply by, let us click the horsepower variable, okay, let's close the bracket and plus, and let's do the y-intercept, and again do not forget to fix it because the values will move down, okay, fix it, hit enter, and here are your predictions. Now let us take a look at how we can evaluate this using the evaluation metrics. The three most common evaluation metrics are the mean absolute error, the mean squared error, and the root mean squared error. So let us see how we can calculate each of the evaluation metrics. Okay, so now first let me do actual minus predicted. Okay, now let us do that. Okay, so now let's do the actual minus predicted. Okay, and let me do this as the absolute value, otherwise they will calculate, they will cancel each other out. So let us do absolute. Okay, let us do that. Okay, this is the absolute value. So now the mean absolute error is calculated as the average of these values, equal to average and let us calculate these values here. Okay, let's do that, and now this is your mean absolute error. So now let us see how we can calculate the mean squared error. So actual minus predicted, okay, actual minus predicted raised to 2. So now let us do this here. Let us go to the actual minus predicted. Let us go to the predicted. Okay, let us raised to the power of 2. Okay, and now we'll do the average of this. So the mean squared error is equal to average of these values. Okay, and then we'll do the RMSE, root mean squared error is equal to the square root of the mean squared error. So now what these what these values tell us. So the mean absolute error, it gives us the average error, that is the average deviation of the predicted value from the actual value. So here it is 3.75. You can see it is fairly good of the so the predicted MPG on average deviates from the actual value by plus minus 3, and the mean squared error is used to amplify any large deviation. So in case for your business, it is very important to note if there are large deviations in your predictions which may actually impact your business, because we have seen that the miles per gallon generally decreases as the horsepower and the displacement increases. So but suppose there's a case where there's a large deviation from this, it may be important to your business, so then you need to take a look at the mean squared error, and the root mean squared error is nothing but the square root of the mean square error, where it normalizes the mean square error to some bit so it can be comparable to the mean absolute error. I hope you understood how to calculate your evaluation metrics and what your evaluation metrics mean, because if you understood this, then you can easily build your linear regression model and then find out how effectively it is performing in the real world. I hope you liked the video. If you did like the video, do not forget to subscribe to my channel and leave a like and any comment that you would on the video about any other video that you would want me to make. Thank you.